Okay, the question here says, um, the question here says, with respect to the origin of, with respect to the origin of points A, B, C, D, and F, got position vectors that are given as we can see there. So the line M passes through points A and B. Find the vector equation for M. So now, according to the mapping scheme, they use the direction vector BA instead of AB. So for the direction vector AB, we are going to say sorry, for the direction vector BA, we are going to say OA minus OB. Then it will give us BA, which is 1, 1, 5, or rather 1, 5, 3, which is A. 1, 5, 3, which is A, minus 0, 4, 1, which is B, to give us the direction vector 1, 1, 2. So that's the direction vector that we have. And the equation of the line is as good as R is equal to OA plus the direct lambda BA. Okay. So this will give us return R is equal to the vector OA is 153 plus lambda the direction vector that we have 1, 1, 2. So that's the equation of the line that we have. That's the equation of the line with a position vector, this one, and the direction vector, this one. Then the second question is to find the intersection of line M and line. Find the position vector of the intersection of M and the line passing through points C and C. So what we're simply going to do is to say CD is equivalent to OD plus minus OC. Then this we can actually have OD now is 3 minus 5, 4. That's what we have for OD. Then we subtract OD 3 minus 5, 4. Then OC is minus 1, minus 3, 1. Okay. So this will give me the value of CD being equivalent to C minus C 3. That's the direction vector CD. So I'm going to set an equal point to M. Set that point equivalent to a point that is equivalent to M. So what I'll simply do is that I say 1 minus 3 1, which is the direction vector of OC, plus X, what I calculated the direction vector of CD. So this is the equation of the line which is passing through CD. Q minus Q3. Alright, that's alright. Then I'll set it to being equal to the line passing through AB, which is M 1, 5, 3 plus Q, that gives me 1, 1, 2. Okay, Then I can now equate this maybe from the x coordinate. I'll say from x coordinate. From the x coordinate, I'm going to have 1 plus 2x is equal to this 1 plus 2. Okay? Then if I solve out that one, I'll get 2x is equivalent to 2. That's equation number 1. Okay? Then from y coordinate, from y coordinate, from y coordinate, there's 1 minus 3 minus 2x is equivalent to 5 plus 2. Then, of course, if I would substitute the value of the 30, then that's not take my okay. So I can actually get more space here like this. So this is equation number 2. This is equation number 2. Okay? So if this is equation number 2, what I'm simply going to do is to substitute what I have on equation 1 into 2. So 1 into 2 is equation number 2. So what I'm going to get is we have minus 3 minus 2x minus 2x being equivalent to 5. Alright. So if I solve out for x now, I'll get minus 4x is equivalent to 8. Then x is equal to minus 2. That's the value of x. Then if t is equal to 2x, it would mean that t will be equivalent to 2 times minus 2 is equivalent to minus 4. Okay, that's fine. So the next thing is to check out if the simultaneous equations work. So if you substitute what I have for s and for t, check out if the simultaneous equations work. So for 1 plus 3s, it is good as 1 plus 3 minus 2, which is equivalent to 1 minus 6, and that's equivalent to 5 minus 5 negative 5. Okay, then 3 plus 2 is equivalent to 3 plus 2 minus 4 here. That gives me 3 minus 8, which is equivalent to negative 5. So we can say that it works. So if it works, I'm simply going to get the vector s is equal to minus 2 into the line passing through C and B. S, the vector S is equal to minus 2. I'm now putting it into the line C is equal to SCD, yeah, which is this line actually. Alright, CD like this. Okay, so these two get me 1 minus 3, 1 minus 3, 1 plus minus 2, 2 minus 2 3. And if I solve out this will give me going to give me minus 3, 1, and negative 5. That's 5 is our answer. Our answer is negative 3, 1 minus 5. That is the uh, that is the position vector of the point of intersection of M and the line that's passing through CD. Okay, the next question, and the last one, you can find the position vector of the foot of the perpendicular C to M. Find the position vector of the foot of the perpendicular C to M. Okay, so the foot of the perpendicular C to M, we are actually saying that let P be a point on M, let P be a point on M. So if it happens like that, we're saying that P substituting C inside will be 1, 5, 3 plus P 1, 1, 2. Alright, that's fine. So the vector P putting P inside is as good as saying alright, rather if I can take this this side, I would actually get CP. P is as good as equivalent to P substituting C minus K. In case that, like, if I would take this direction vector, yeah, I would take it in this side here. I would rename it C. That's what I do. So P, 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 is equivalent to that. So if I would take this point here, and I will bring this back, what I'm simply going to get is 1, 5, 3, minus 1, 5, 3 minus 1, 5, 3, or rather, it's 1 plus P minus 1, then 5 plus P minus 3, then 3 plus PG minus 1. Then this will give me P 8 plus Q, Q plus PG. Okay, that's what I have now. Then the perpendicular to the direction vector, perpendicular to the direction vector D, I've got perpendicular to direction B. I have it's actually equivalent to 1, 2. Okay. So what happens, I'm now taking this one here, which is 1, 1, 2, multiply it because they are taking the two at each other, 2, 8 plus 2, 2 plus 2, 2, then this 1 plus 1 here, 8 plus 2, I'm multiplying, scalar multiplication 2, 2 plus 2, 2, okay, then if I would simplify this one, I would get 2 is equivalent to negative 2. So we are going to say that P, then P E. P is equal to at P is equivalent to negative 2. So if you keep like that, it would mean that 1 it would mean that 1 because we have got the equation of the line P is because we assume that P was equivalent to T was a line that's laying in M. So PT 153 plus T 112. Now we can substitute for the value of T that we found in T is equal to 2. It is 153 plus negative T 112. Okay. And if I would solve out for this, I would get minus 1, 3, and 5 equal to answer. Is the coordinate that I'm looking for.